Semester test review number 17 through 20. We are looking at the characteristics of the following graph. Number 17, we're looking at a graph of a line, which is linear. Your domain is always your x value, and it goes from far left to far right. So, your far left, it starts way over here, and it's approaching negative infinity. That's where it starts. Your far right is approaching positive infinity. So you write your domain, parentheses. Your domain is always in parentheses if it is an infinity. So negative infinity to positive infinity. So there you have your domain. Your range is always your y value, and that y value starts at the lowest, which is like your floor, all the way to the ceiling. How high can you get? Your lowest value here starts at negative infinity, and it's heading toward the positive infinity. And that is your range. Your end behavior on the left, we are talking about this side right here. What is taking place? As x is approaching negative infinity, the y is also approaching negative infinity. Therefore, you write it as x is approaching negative infinity, that's my infinity, your y is approaching negative infinity as well. Regarding the end behavior on the right, it would be talking about this one right here. What is taking place? As x is heading toward the positive infinity, your y is also heading toward the positive infinity. So therefore, you write your end behavior as x is approaching positive infinity, your y is also approaching positive infinity. Your interval increasing. Look at this graph. What is taking place? It is increasing continuously. Where is it increasing from? Well, it starts down here. It is always your x value. And what is that value? It is negative infinity. Where is it heading toward? It's heading up toward the positive infinity. Interval increasing is always in parentheses. Regarding interval decreasing, if you look, this graph is not decreasing at all. So this graph does not apply regarding decreasing. Your x-intercept, where does it cross the x-axis? It crosses right here at 2. And what is that point called? You can write it x equals 2, or you can write it as an ordered pair, 2, 0. Don't just write 2, because I don't know what you mean unless you write x equals 2. Where are you crossing the y-axis? The y-axis is crossing at negative 4. So y is equal to negative 4. Therefore, you can write it as y equals negative 4, or you can write it as an ordered pair, 0, negative 4. So there you have the characteristics of a linear. On number 18, we have a characteristics of a parabola. So let's take a look at this one, okay? Before you start, notice your lowest point, your minimum right here, is 3, negative 4. That is your order pair. So that might help you a little bit regarding your range and domain later on. As stated before, your domain is your x value. How far left is it starting? Where is it starting from on the left? Is it right here? No, there's an arrow, so it continues. Did it start here? No, but it starts way over here. And what is that called? Because we don't have a definite point, we are starting at negative infinity. Where does it go on the right? How far right does it go? It doesn't stop there or there or there. But where is it going to stop? Somewhere way over here, and that unknown we are going to write positive infinity. So it's somewhere over there. Your range is your lowest point. What is your lowest y value? Well, that lowest y value is right here. And that y value is negative 4. You can look at that point right there. And since it is included, you're going to use a bracket, and you're going to write negative 4, how high does it go? It continues on and on and on toward the positive infinity. That's where the ceiling is. your end behavior on your left, that would be this one right here. What is taking place at that moment? Well, what is it? Your x value is heading toward, coming from the negative infinity, it's heading in that direction for your x. But what is taking place for the y? It's heading toward positive. So you would write, as x is approaching negative infinity, my y is approaching positive infinity. Okay, don't forget your commas. The right side, that means we're talking about this side right here. What is taking place at that point? Well, my x is going towards positive infinity. What is my y doing? Well, your y is also approaching positive infinity. So as x is approaching positive infinity, your y is also heading up as well. Think of north and east, okay? Interval increasing. Where do you see a graph increasing? It's increasing starting at this point all the way up. And when you are looking at interval, you're always looking at your x-axis. Where is it starting on that x value? It is starting at 3. And it's always a parentheses. 3, comma. How far right did it go? It is approaching positive infinity. You're decreasing. Where is it decreasing? It is decreasing from right here all the way down, but it stops at 3. So how far left did your decreasing start? It starts at negative infinity, but it comes all the way down along your x value, your x-axis, but it stops right here. And what is that coordinate? That is 3. Intervals always in parentheses. Your x-intercept, where are you crossing the x-axis? I'm crossing right here at 1. So x is equal to 1. I'm also crossing at 5, comma, x equal to 5. That's an x. Or you can write it as 1, 0, ordered pairs, 5, 0. Your y-intercept, where are you crossing the y-axis? Right here at 5. So y is equal to 5, or you can write it as 0, comma, 5. Your choice. And there you have your characteristics of two different graphs. On number 19, we are now going to look into arithmetic sequence. Arithmetic means that it is going up at the same pattern or going down at the same pattern, okay? Take a look at this pattern we have on number 19. I'm going to make this just a little bit bigger. Hang on just a moment. There we go. Okay, arithmetic sequence. Now, take a look at number 19. We want to know if these numbers, or is there a pattern to these numbers? So what you want to do regarding arithmetic is you always want to take the second number minus the first. So if you go negative 12 over here minus negative 2, that gives you negative 10, okay? Do it again right here. Negative 22 minus negative 12, that gives you negative 10. So you're starting to see a pattern, and that pattern is I'm going down 10 every time. So your D is equal to negative 10. This very first number is called the first term, x1. It's just naming it. That's all it is. Now, you notice how it goes down in pattern? Therefore, this is an arithmetic sequence. So the answer is yes. Your explicit formula means it's a formula that you are going to come up with, and it has a starting point. So you will write xn equal, what is your first sequence? What's that number? Negative 2. How far is it going down every time? Minus 10, n minus 1. N means what number are you looking for, okay? Your recursive formula will look like this. Recursive is a general. It can start anywhere, but you know you're going to go down 10. So xn. So you want to take your first term, your second term, pardon me, minus first term. So that would be x n minus 1, the term you have, minus the 1, minus 10. That is your D. Therefore, Now you want to look for your second term. So what formula would you use? You would use that explicit formula to look for your 52nd term. This is your n, that 52nd term. So you have x of 52 equals negative 2 minus 10, 52 minus 1. What is my 52nd term going to be? It's going to be negative 5, 1, 2. So instead of me going down minus 10 all the way to 52, I plugged in this formula. And for those of you who might need the general formula in case you forget, here is your explicit formula. It is xn equal x1 plus dn minus 1. Okay? For your recursive, it is xn equal xn minus 1 plus d. So there are a couple of things that you really change, and everything else you just plug in. You need your first term, and you need your d. For the second part, you just need your d. That's all you need. Let's look at number 20 now that you have this information. Okay? On number 20, let's see if you see a pattern. What is taking place? When I subtract these two, I notice I'm going down by 200 every single time. So that's my d. d is negative 200. Okay. Is this an arithmetic sequence? The answer is yes. Write the explicit formula. Remember, this is your first term right here. So you're going to have xn equals 28 minus 200 n minus 1. Your recursive formula, xn equals xn minus 1 minus 200. So I can start anywhere. That's the general equation. 52nd term, do the same thing. I'm going to use the explicit. 28 minus 200. What is my n? 52 minus 1. And when you plug that in to your calculator, you're going to get a really low number. Negative 10172. 10,172. That will be your 52nd number in this series. Thank you. Please look for the next page.